Today, before that, what is BWSI? All right. So today we have a great speaker from Lockheed Martin. Lockheed Martin is one of our platinum sponsors, and so I'd like to ask them to raise your hands. That's the Lockheed Martin team. All right. The Keoki Jackson, who's their CTO, he's not here today, but he'll be here tomorrow and Saturday and Sunday. But I do want to say a few words about my interaction with the Keoki. Last year, also we were scaling up the program from 3 projects to 8 projects. Of course, we need additional funding, and we approached Lockheed Martin. And I still remember the morning I was driving to work. I received this email from Keoki saying that Lockheed Martin will be one of the sponsors for the project. And so, of course, the funding sponsorship is really great, but just as important to me is his enthusiasm and his belief in this program. So really great thanks to Lockheed Martin for being one of our sponsors. Today, we also have some visitors from Southwest Indian Polytech Institute, if you can raise your hands. All right, so they'll be here today through Sunday. They've set up their presentations and demo at Vivo Workspace. So some of the classes will be go visit them for like 15, 20 minutes, class by class, to see some of the very interesting work that they are doing. So we'll be arranging that with the instructors, right? So that'll be this afternoon. So let's now welcome the speaker, but we'll do by class. And so I'm gonna have 10 fingers. There are 10 classes. I'm gonna try to remember this. So, UAV racing. Yeah! Cogworks. Yeah! Medaletics. Yeah! All right, that's 3. Build a CubeSat. Yeah! Embedded security. 3D printing. The assistive technology. Remote sensing. Okay, and finally, the last, the race car is the Lockheed Martin project. So let's hear it. and the team. I think I only have 9 fingers. And UASR. So I guess you'll go first again for lunch. And I'm sorry, I'm really not trying to do this, but somehow I always. And the team from Mexico. All right, with that.
You guys hear me? I've never had 10 separate rounds of applause before, so thank you for that first. That was impressive. So my name is Keith Lynn. As you heard, I work with Lockheed Martin. And I'm going to tell you a little bit about the program that I'm leading today and a little bit about what we're doing in the area of artificial intelligence and autonomous systems, which I'll show is relevant to everything you're doing. I see the different posters in the back here. I think you're all aware that all of these different things have something to do with artificial intelligence, or artificial intelligence could have something to do with them in some way, which is why I titled this talk AI Across All Domains. Domains having an AI in it, so, trying to be clever. You may know some of my colleagues here. Sunny Wicks is sitting in the front here. Sunny's great. I've worked with her for a while. She knows a lot about advanced materials and manufacturing. And she's sitting next to Dr. Darren Brock, who I worked with for quite a while in the UK. We used to drink tonic water in the Paddington station together every month, and eat sushi, and it was a good time. And Dr. Brock is an avid amateur breakdance professional. I don't know if you know that. Doesn't look like it, but he's pretty good at it. You never know. All right, so I'm going to start off with a little story about the past that I think is kind of fun, and will lead into why I'm talking about artificial intelligence. So take yourself back to a century ago It's the 1890s. It's a really impressive time to be alive. There's this strange thing going on in Paris. They're building some kind of antenna, something like that. It's a monstrosity, eyesore, who knows. People are taking on new fashion, taking it to new heights. I mean, look at this guy. That's going to last for a long time. And trains are falling through buildings. So yeah, what an amazing time to be alive. So the future's looking bright, I would say. Wouldn't you say? Wouldn't you want to live during this time? Yeah. So despite all this goodness that's happening, there are some looming problems. And you might be thinking, wars and things like that, and sure, but something potentially bigger than any war. Yeah, he looks pretty ominous, doesn't he? Well, it's not him. It's the horse. Yeah, the horses are a real problem, guys. They're going to be a problem if we keep using them the way we're using them, because their poop is everywhere. Their poop is building up so much. It's hot. It's smelly. We're going to be trapped inside by these mountains of poop, and society is going to grind to a halt. Because what can we do? There's no alternative. This is our future. London Times, back then this was, the newspaper, is saying in 50 years, there's going to be 9 feet of poop covering the streets of London. 9 feet. That's taller than a human. I don't know if you can see it, but this silhouette actually kind of looks like Daniel Craig, so I like to picture this as James Bond standing next to a giant poop emoji, but that's just me. So people were saying, this is it, we're at the cliff. Society's going to break down. But then some people had a crazy idea to move to a different type of modality, and called it the automotive carriage or motor carriage or automobile. There were a lot of names for it at first. And they said, hey, it doesn't poop. It'll be good. And that was it. Problem solved. But not really, not for a while. Turns out people didn't really like this thing for a long time. It was rather expensive at first, limited supply. It's only the wealthy people that could afford it, and they used it more as a novelty, which kind of ticked off the people who weren't so wealthy, and they would try to sabotage them early on because they didn't like the rich people showing off with their toys, and they were a little bit loud, and they had their pros. That you can see here, the advertisement says it's handsomely and strong, yet lightly constructed. So who wouldn't want something that's so handsomely and so strong, right? And it's easily managed, and it doesn't poop on you, and all those other great things. It doesn't have any odor, so why wouldn't you want one of these? Well, $1,000 was a lot of money back then, and there were a lot of people who worked in the horse industry. There was people that were picking up the poop. There were people steering the carriages, managing the horses. They needed to sleep and eat, changing their shoes. So this was a huge industry, and people said, I don't want to lose my job because some guy put 4 wheels on a box and is going to go around that way. That doesn't make any sense, right? So it took a long time. People didn't want to change. They didn't want poop, but they didn't want these things putting around town either. But then something really interesting happened. Somebody got really inspired or really bored or both, and they decided to start racing these things. And they used to rip down the old dirt roads and have a good time. People would be watching, and they say, what the heck is going on? And then the people look like they're having a good time, so they kind of got into it, and they'd start watching, and people started organizing shows, and then some of them even started crashing, right? And people thought, hey, that's pretty funny. I want to see more of that, right? So that really helped people accept this strange new thing. And they started to get curious about it, and they thought, okay, maybe there is something here. Maybe I want to get one of these one day, right? Maybe I should learn more about it. Maybe there's a career for me in this, right? That's how it got started. But it took over 30 years for that to happen. The automobile was invented a long time before. It was showcased in France. That's why we have French words in our vocabulary, like garage and chauffeur, right? Started in France with the aristocracy. Took over 30 years until it became a staple of the mainstream economy. But, the automobile today is considered a fabric of life. It's an art form. It's used everywhere, from law enforcement to construction to health services, right? We even put a car on the moon, right? And every year, about 60 million vehicles are built worldwide. And it's estimated that to build 60 million vehicles, you need to employ about 9 million people. So this thing that was originally going to put thousands upon thousands of people out of work just to save a little poop now employs billions of people, has employed billions of people. So, there's a couple lessons in this that I think we should all remember. First is that unsolvable problems are nothing new. There's been doom and gloom from the beginning of time that, people didn't like the printing press at first. They thought, this is going to take away the human art to the written word. They didn't like the telephone. They didn't like the internet. They thought it was a toy, a novelty, a distraction. Right? So all throughout time, people have not liked technology, and they felt like problems were just flat out unsolvable. This is it. We've hit the end. We don't know how to envision a brighter future. And it hasn't been true. So that's not going to change. It's been consistent. And the amazing things people have come up with to solve these problems were not always accepted very quickly. Initially, skeptics would say that, oh, it's limited, it's a toy. Then it would have some early success, and people would say, yeah, okay, so it has a small market, but it's not going to take off, right? And it's only going to be used for very specific things, right? There's no way anyone other than a wealthy person trying to go to Sunday brunch is going to use an automobile. Why would they, right? It's just too much, right? They don't envision, oh, well, maybe this will transform how we fight fires and how we get sick people to the hospital and how we go long distances and how we have fun and entertain ourselves in all different ways. So people are usually narrow-minded in the beginning. The third lesson, and the one that I'm going to talk a little bit more about because it has something to do with my program, is that play and entertainment have a role in technology. If it weren't for the people racing cars and crashing them and getting other people to look their direction, maybe it would have taken 40 years or 50 years until people started to really adopt this. The price point would have been there, but if they didn't feel a need to buy it, they wouldn't spend the money on it, right? If they weren't excited about the technology, they didn't feel like it had a part of their lives, why would they invest in it? And then finally, and I covered this a little bit already, is that society adapts to change. What seems like an initial setback or something strange or an initial limitation, in the long run, when you're talking tens of years on top of each other, turns out to be something indispensable. You look back and you think, how could the world exist without the internet? It changed everything. How could it exist without cars? Changed everything, right? And at first, nobody thought that. So you have to look at new things in the aggregate and the net present value of everything they are going to create for years to come. So with that, I'll start my presentation. I didn't show those other charts to the Lockheed folks before I started because I thought maybe they wouldn't like to see the poop emoji on there. And I just added them this morning, so hopefully you guys weren't too offended by that. But my name again is Keith Lynn, and I'm a program manager for AlphaPilot, which is a public innovation challenge, like an X Prize, where we're doing autonomous racing. And I'm going to get into that in a minute. Does anyone know what a program manager does? Yeah? Manage the program, right? So, yeah, you're not wrong. Program manager, so I'm not an expert in artificial intelligence, but I work very closely with it. I have team members who are experts. They help me achieve the technical milestones of my program. But I'm responsible for managing their success, handling their failures, making sure that we have a good marketing communications plan, making sure that we have a strong, sound legal agreement with all our parties, managing our suppliers, our contractors, our partners, managing our executives. And sometimes they need a lot of managing, right? So it's all these things. So that's what I do. So I heard you guys really like technical questions. I'm pretty good at answering some of them, but you might stump me. So I'll take some questions at the end here, and I'll do my best. But I might just go, I don't know, work with me. So let's start by defining artificial intelligence. So this is something that always has intrigued me, because we have a lot of really smart people at Lockheed, and they all think they know exactly what artificial intelligence is. But if you put them in a room and you ask them to reach consensus, you could walk away and come back a day later, and you might find a couple dead bodies in the room because they either fought each other to death or they talked so much they ran out of oxygen. And there would be no consensus, right? Now, there's consensus around elements of it. Everyone thinks it's certain to do certain things and whatnot, and I think that's true, or it should augment certain functions that humans do, right? But I haven't heard a very concise definition of it. I've heard a lot of these words thrown around, right? Some of them are, going more the route of the tactics that it employs. Others are more high level about what types of functions it can perform. So what is it? Does anybody want to offer up a definition? Any volunteers? Yeah.
Getting machines to do things that normally only humans can do.
Getting a machine to do things that normally only a human can do. Okay, that's a good definition. Any others? Thank you. Yeah.
Getting machines to emulate human intelligence.
Emulate human intelligence. Okay, thank you. Let's do one more. Got one?
Allowing the machine or program to adapt to the situation and do something that wasn't directly programmed.
Okay, so yours is more along the ability to adapt and learn new things that it wasn't programmed to do or trained specifically to do, right? Okay, so I've heard that a lot as well. So I had this debate. We were actually up here a couple weeks ago for an event on my program, and I had a chance to chat with some of my members of my technical team, and the big difference that came up was some people were defining it around the ability to learn and adapt, like you're saying. Others, it was just the ability to replicate human functions. So these are all great definitions. Thank you. I took one from the web. This is a pretty commonly accepted one. Computer systems able to perform tasks that normally require human intelligence. So you guys are pretty spot on. Give yourself a round of applause. That was great. So great, now you know what it is by definition. What does it look like? What does it do? Right? Is it an autonomous car? Is it Alexa? Does it have to be able to talk to you, understand what you want, tell you what time movies are playing? Is it I think that's Starship Robot, delivers food. I don't know if any of you live in Washington, D.C., you may have seen these things around. Yeah, they're pretty cool. And then this robot's called Pepper. This is a human assistance prototype robot. This is to help people with disabilities or elderly with different needs where they might be limited. So are these things all AI? Are some of them AI? Or some of them autonomous systems? Are autonomous systems AI? What about robotics? Is it R2-D2? Is that really what AI is? The can do anything and everything robot? I don't know. Means a lot of things to a lot of different people. Some people try to measure it objectively. Things like the Turing test. Anyone know the Turing test? Yeah, it's gotten more popular. Anyone see the movie Ex Machina? Yeah, that movie's based on the Turing test. The Turing test basically says if you put someone isolated in the middle from a terminal or a human, and they're talking alternatively between the two, if they can't tell which one's the human, which one's the machine, then it passes the Turing test. It has to be able to replicate human functionality to the point where you can't distinguish, apart from seeing it, if it's a human or a robot. Okay? So that's one objective measure. That means that it has to be good at conversing with a human, has to be quick on its feet, has to be witty, right? Might not, you can sniff it out. If it gives you a very weird answer, then it doesn't pass a Turing test. But it doesn't mean it's not good at what it does. So it's not a perfect definition. but it's at least a step to objectify what it is. The reason it means many things to many people is because it's used by many different people in many different ways. So this is a snapshot of the different sectors of the economy: healthcare, finance, utilities, transportation, energy, materials, consumer goods. And they're all looking at artificial intelligence in different ways to help drive new capabilities, reduce costs, lessen the load for the human employees, or allow humans to do what they do best and not worry about the other things. Artificial intelligence is a new skill set that has to come together with historical, traditional skill sets. So for me, that would be aerospace engineering, electrical engineering, manufacturing, right? And the different ways you define AI depend on how you combined those traditional needs and knowledge blocks with the new AI skill sets. So not only does it mean many things to many people, it's going to touch the lives of many different people. So right now, it's something that is familiar to young folks like yourselves, to people in the academic community, and to some people in industry that are well-versed in this and forward-leaning. But I like to call this the astronaut to grandma scale, right? So think about the future and think about how are you going to get people in their 80s, 90s using AI at the same time that people doing space exploration are using AI. They're going to both be using it, just in very different ways, and it's going to mean something very different to all of them, right? So right now, how many of you think an astronaut would be comfortable depending on artificial intelligence to help with their mission and keep their lives safe? I think that's something an astronaut would be willing to do. Okay, quite a few of you. Do you think it's something your grandparents would be willing to depend on? Do you think your grandparents would hop in a self-driving Uber to get to their next doctor's appointment? No? Some? All right, some of you have really forward-leaning grandparents. I admire that. My grandfather's 94 years old, and he's, I wouldn't say proficient at using an iPad, but he tries really hard, and I'm his personal tech support, so I'm proud of him for that. But he hasn't broached the subject of AI yet. So to me, I think that there's work to be done to get to a world where the people on the everyday side of the spectrum are comfortable using artificial intelligence, or at least curious about how it could improve their lives. So how do we do that? How do we make it accessible to everybody, to people who won't ever understand how it works, but are willing to use it? Many of you probably climb into a car every day, and if that thing broke down and no one was there to help you, you wouldn't know how to fix it. But you use it every day, and you're comfortable using it, and you trust it, and it's reliable, right? How do we make that the scenario for AI? So here's one strategy. It's the one that I'm using on my program. It's to build a fun and compelling challenge. Think about the automobile racing, right? It was strange to a lot of people. They turned it into something that was familiar, play, excitement, racing. Why is racing great? It's easy. What is racing about? Going fast, being the first to finish, right? It's pretty universal. Racing is racing. I actually looked at some other scenarios for my program, capture the flag and whatnot, and you lose people very quickly. They go, what is it? What are you trying to do again? I just see things moving around. But racing, super easy. Something that's a challenge format, it's a call to action to people, gets people engaged. That wouldn't be part of that initial click. You bring diversity into it, so people from different walks of life get involved. They have different reasons for getting involved and motivations, which is really nice. They bring fresh ideas. And you use cutting-edge technology. You put the best things available out there for people to play with, people that might not otherwise have access to it, right? So that's how you get people who are intelligent and already slightly inspired by the discipline to get involved. What about the other people? The people that have nothing to do with it. You make it visible to them, and you make it fun. You tie into existing fan bases. You find what people are already inspired by. Find the connections. How do these things link up? How does this take that one step farther? You create entertaining content, right? So you have to present it in a way that keeps people's attention. It can't be boring. It can't be too scientific. It has to be just the right amount of educational and fun, right? So you need the right medium. And you need to celebrate the achievements, right? So one thing I say all the time on my program is we have to celebrate the humans behind the code. AI always seems humanless, but it's a human endeavor. Humans are writing the code. Humans are maintaining it, improving it, making it safe, making it secure, right? Regulating it, all kinds of things. So let's tell their story. Let's make this personal, right? So let me talk now about my program, since I've mentioned it a few times. Has anyone heard of AlphaPilot? Yeah? Great. Wow. That's fantastic. What's that? Oh, OK. You guys are the repeats. Sorry if I'm boring you then. So AlphaPilot is a challenge where we decided to make autonomous drones a racing sport. And turns out drones are already a racing sport. Quite a popular one, actually. It's the largest growing sport year over year. Drone Racing League. Everyone heard of Drone Racing League? Yeah, anyone watch them on TV? They've been on ESPN. So they've gotten quite popular. They have about 80 million viewers worldwide every year between ESPN, Sky Sports, ProSieben, and then some online content. So we thought, hey, that's a great existing audience of people who are already watching technology at play. Let's tie into that. So we formed a partnership, we being Lockheed Martin, with the Drone Racing League. And we said, hey, let's put the best hardware possible on these drones. If we want people to fly them autonomously, they're going to need a lot of computing power. So we went to NVIDIA and we said, what do you got? And they said, well, we're about to release the new Xavier GPU. Does anyone have an Xavier? Yeah? So the Xavier is the next in line after the TX2, Tegra. And we said, has anyone ever put this on a drone before? And they said, no, dude, we just came out with this. And I said, awesome, we're going to be the first. So we decided, OK, we're going to have new technology no one's ever played with before in this capacity. We're going to have a new twist to an existing sport. And we're going to see what happens, right? So we decided we were going to put out a challenge worldwide. We wanted it to be about the code and not the hardware. So we decided we're going to have to create a whole new drone and standardize it for every team. We're in mass production right now. There's going to be about 400 of them. 400 because we expect a lot of crashes, right? And we had 430 teams sign up to do this from around the world. And we down-selected them to 9 using a simulation challenge that was designed right here at MIT by Dr. Karaman and his team. So then what? We got 9 teams from an original 430, something like 3,000 people if you count them individually, plus additional ones that were just there following for fun. So that was quite an achievement to get past all those other people, make the down select. So we wanted to get them excited. We said, hey, look, congratulations. You're part of this journey with us now, for better or worse. But you're going to get a cool jersey out of it. You know, it's got your team name on it, nice color. And we're going to film you. Your code is going to fly in these drones. We're going to have 4 races this year. The winner is going to take home over $1 million in prizes. Oh, and the 4 races are going to be televised on NBC Sports and Twitter. And we're filming a documentary. So not only is your code going to be on TV, but so are you. And we're going to capture all those moments where you're saying things you shouldn't say and throwing things and falling asleep at the table and all that great stuff, right? So that's what we did. We tried to take something that was, we're not the first ones to try this. Anyone hear of IROS? Robotics Competition Conference every year. They did autonomous drone flight. But the drones there, everyone brought their own. It was BYOD. And those drones are expensive, so people don't want to crash them. They want to fly them fast. And it's kind of a niche audience. So we said, all right, we could do better. We can mass produce the drone so people don't care if they crash it. It's not their baby. Right? and we can spread out the course so they're going fast. We created a drone that can go over 80 miles an hour. So if they want to fly fast, they can. They're encouraged to push the boundaries. And we put it on television as a racing sport, right? It's a great way to sneak a really high-tech technology into something that's pretty easy for everyone to grasp, right? You can sit at home with potato chips and watch racing, and racing's racing to you. And you don't know it, but you're getting more indoctrinated to artificial intelligence while you're doing it. So that was our move. And you can see here a photo. This is the Status Center, which is just one building down. These are our 9 teams lining up to go to the motion capture laboratory, building 31. They're from all around the world. You can see here some of them working on their code in between different runs in the motion capture laboratory, talking to some of the Lockheed mentors, strategizing. It's a really interesting event. It's very stressful to try and pull something together like this. This is in the realm of program management where you have 100 moving parts and 800 or 80 of them are trying to go wrong at any given moment. But that comes with the job. And we had a really great event. We learned a lot. We improved our drone. We improved our simulator. And we're now about 1 month out for our first race. A little more about the teams. We have 3 teams from the US. We have a team from Switzerland, a team from South Korea, a team from the Netherlands, a team from Poland, a team from Brazil. And then we have this weird amalgam team called Team Puffin that started out with just 2 people in Sweden. And then they basically cherry-picked people from the teams that didn't quite make the down select, but almost did. And now they're a Swedish, South Korean, Australian, American team, which will be really interesting to watch how they coordinate across all those countries and time zones. I'm rooting for them, actually, because that would be a pretty awesome achievement if they win. So I mentioned we have 4 races this year. First one's going to kick off August 22nd. That one's a private event. We don't want these people to be too spooked the first time out of the gate. So if it doesn't go that well for them, that's OK. But they're going to have more time to train in between. And the second one will be in September. The third one will be in October. The fourth one will be in November. And then someone is going home with $1 million. And hopefully multiple teams are able to fly their autonomous drones through the courses at some pretty high speeds. Right? It's going to be a fun journey along the way. We're going to have a lot of crashes, a lot of heated moments. What do you think? Does this sound pretty cool? You guys would watch this if we're on TV? Would you watch it if we're on Twitter? Yeah? Yeah? Cool. We designed this to get people like y'all excited, so that's good feedback. I didn't hear any boos, so that's good. Put it on Netflix, the documentary? Or Twitch. Yeah, that was a good call. OK, I heard some groans with Twitch. Maybe it's Twitch already kind of past peak popularity? All right. Well, NBC Sports, DRL just negotiated with NBC Sports, so that'll hit a mass audience, and you can watch it on NBC Sports online if you don't do the TV thing, and Twitter. And yeah, we might explore some other mediums as well. I've already looked into Twitch a little bit, so thanks for those suggestions. So how hard is drone racing? Has anyone ever raced a drone? What about flown a drone? Yeah? What do you think? Was it easy, hard? Easy, OK. Is it a commercial drone or what? Like a DJI, something like that? Yeah, Intel drone, OK. Well, it turns out the racing drones are a little bit harder. Those commercial drones have a lot of stabilization software already built into them. So whether you know it or not, the machine's already assisting you. I've tried flying a racing drone, a little one. They gave me like a little one you can't break, or can't break you, I guess more importantly. I tried flying that at one of their events, and I just kind of did one of these, you know. But it was a lot of fun, and they all have a first-person camera, so you put on the goggles, and you can fly it around like that. And if you get motion sick, then you really feel sick, so you just rip them off. But it's amazing watching the DRL professional pilots. They fly these things with such grace. It's really impressive. So the reason I ask if you've done it before, if you have any interest in doing it, is because everyone here, courtesy of the Lockheed team, is going to be taking home one of the Tiny Whoop racing drones. And this is it right here. So the plan was to. So I wanted to do the Oprah thing and say, if you reach down under your seat, each of you will find a. But logistics is a big part of program management, and there were some shipping delays, but you'll get them tonight at the end of the day. So something to look forward to. So it'll come as a kit. You can assemble it yourself. You can fly it around. They're very harmless. I'll show you a video in a second. But we want you to fly them, crash them, get inspired to do some cool stuff with them. And if you do come up with something really fun, share it with us on Twitter or wherever. Just hashtag AlphaPilot. We'll get it. Oops. So here's a link of one. You can see it in action. This is from Tiny Boops. That's an ad. That's a baby. That's not a drone. It's not up there? Oh, OK. Hold on. Technical difficulties. Any idea how to do this? No. Okay. It's just set to share to PowerPoint for some reason. Yeah, I just want to make that big. All right, cool.
It did split. So.
I might need you in a second when I take it off.
Yeah, hit start.
All right, so I just thought this was a cool video, the Tiny Whoop. Someone decided to fly it through a crabapple tree. And I don't know, they got some really cool video out of it. You can see it first person when you're flying it, what it's like. It can move these things to really tight spaces. You can bump into stuff, and they're pretty indestructible. So I'm sure with all the clever minds in this room, you could find something really cool to do with yours. This is a first-person view. I don't know. Check in the box. All right, so that was the crescendo of my presentation. I'll land the plane now. I just have a few more slides. I wanted to make it more about you guys now, since you're some of the smartest kids in the country, and you're going to do amazing things. And I wanted to tie it back to your program. AI and everything we do, right? So I took your classes here. They're also posted in the back there. You guys are familiar enough with them, right? And I mapped them to some things that we care about specifically at Lockheed Martin that AI is involved in. So autonomous systems, forecasting and prediction, human training, manufacturing, radar, sensors, signals and communications, cyber, space exploration, satellite operations, logistics, right? They all map to some microcosm that you're working on during this course. So that's why Lockheed Martin loves BeaverWorks. That's why we love getting involved with you guys and helping with some of these amazing programs like the Race Car 1 that was mentioned we sponsored. Artificial intelligence, like I said, is everywhere. We often ask ourselves, can we think of a product that wouldn't be better in 10 years if it didn't utilize artificial intelligence in some way? And most of the time, the answer is no. It would be better if we did. Right? So we're looking at creative ways to do that across all domains. When we say domains, we mean from the depths of space to the depths of the ocean, everywhere in between physically and in the cyber realm. Right? So this is one of our aircraft. This is the F-35. We use AI for pilot assistance. We've had pilots, not in this aircraft, a different one, black out while they were pulling Gs. They woke up and the plane was flying itself. It saved their lives. Flew for them, understood that they were going through some kind of trauma and corrected for them. So that's a really cool application, right? Anytime you can save lives is great. Communications link, so being able to cycle through comms frequencies and communicate with a network of different aircraft, people, ground vehicles, ships, everything like that. Right? That's a big play for artificial intelligence. Data fusion. Every time one of these airplanes flies, it pulls down 7 terabytes of data every single flight on sensor readouts, readouts on the human performance, the engines, everything. Right? Making these planes better over time requires us to chew through all that data and extract meaning from it. Right? What is it telling us? Where is there efficiency to be gained? Right? So there's another way. And then maintenance, right? You want these planes to last for many, many years. How do you keep them in tip-top shape? How do you keep improving them, right? Incrementally over time? Keep the wear and tear down. Predict when things are going to fail, so it doesn't happen when the thing's flying. Right? You get to the problem before it becomes a problem. All these different applications are the ones you can see visibly. And then there's the ones you don't see so much. This is more of the engineering life cycle. So how do we use AI in designing an aircraft? Right? What's the next aircraft going to look like? Right? How does AI help us with that design? How does it help us optimize from lessons learned? How does it help us craft different physical models and test them simultaneously in parallel? Same with manufacturing. Same with testing. Once you design something, how do you optimize your tests so you can do the least amount of tests but get the most amount of information out of it as possible? Right? And then also training. How are you going to teach people to use these things they've never flown before or never worked on before in an efficient way and get it up to scale quickly? Right? These are the things that help something like the automobile go from a novelty to mass-produced and mass-used in a much faster time frame than 30 years. Right? It's getting the design down, getting it to scale quickly, training people how to use it, and making sure it's safe and reliable. So aside from airplanes, I mentioned our spectrum of domains. We're putting AI in our exploratory space vehicles. This is the Orion capsule. And it has something called Maya, Model-Based Artificial Intelligence Assistance. So imagine you're 140 million miles away from home, orbiting the red planet, and something goes wrong. You can't pick up the phone and call home. Right? You got to have all the knowledge you can have with you. Right? And sometimes that's more than a single person or a crew can have. Right? So folks in our Space Systems division are coming up with this augmented reality virtual assistant. Reminds me a lot of the thing that Iron Man uses in Marvel, the thing that he talks to, right? Jarvis, yeah. Which is really cool, that think about in a couple years, astronauts are going to be using, Maya or Jarvis out in the depths of space, right? So I like to say that we go from exoplanets to exoskeletons, right? Exoskeletons, another product. One of the guys on my team, actually, one of my comms leads, works on the exoskeleton, and he's put it on, they run around with it, they do all kinds of crazy stuff. And it uses some artificial intelligence to do sensor feedback. So sensors read the human body position, and they figure out how a person holds themselves and how they intend to move. And then the exoskeleton actuates to assist them. Right? And the more a human wears it, the more it learns their behavior, the more it becomes more effective at assisting them. Right? So it's pretty cool technology. We like to play around with it a lot. And who doesn't like a good exoskeleton, right? So to close, AI is everywhere we go. Where and how AI is applied in the future is up to us. It's up to you. It's up to the people who are going to be going into the workforce with a strong knowledge of it, meeting people in domains in energy, healthcare, transportation, aerospace, all across the board, who are looking for ideas and inspiration on how to get past the insurmountable problems they're facing. And it's going to be your combined knowledge and their legacy knowledge that's going to get it done. Right? Diversity breeds excellence. I see a lot of different faces here, people from different backgrounds, coming from different states, different experiences, different cultures. Right? All of that plays a part in inventing the future. You all bring something unique to the table. So if you take one thing away, remember that diversity breeds excellence. We have to build an inclusive ecosystem where everybody has a role here. Not everybody's going to be writing code in artificial intelligence. Some people are going to be writing laws around artificial intelligence, defining ethics, marketing it so people feel comfortable around it, figuring out how to make sure it's safe, how to mass produce it, how to distribute it, right? Everybody has a role in some capacity, right? So make sure as you endeavor to do amazing things that you build inclusive ecosystems for the people who aren't just like you, but are touched by the things that you're doing in some different kind of way. And be enthusiastic. Enthusiasm's contagious. I can tell that's not going to be a problem with the rounds of applause I've gotten with the tiny whoops. So keep that going. Don't lose your spirit, guys. Everything you do is amazing. Keep that enthusiasm going. And finally, the journey from this to this is much shorter than you think. You're already a lot closer than some of you may imagine, and I can't wait to see what amazing things you do. Thank you very much.
So we'll take some questions.
Yeah, we have time for a few questions. Yeah.
Data validation. I've seen an example of you going to some attack crashes. When you place crash because of a failure of the answer of a single sensor, they have attack sensors. So how does Lockheed Martin work to ensure that the data that their model receives is correct? Because the models are contingent on the data being correct.
Yeah, so we have a corporate-wide initiative right now focused on validation and verification. This is something we recognize, and it's something our customers, the military, is putting these aircraft in extreme environments, and they're depending heavily on the sensors, and they're putting humans in dangerous situations. So we need the utmost level of validation. So we're working really hard on creating environments where we can simulate sensor data, and we can test under all different types of scenarios to try and find failure points. But yeah, it's a really hard task. It's making autonomous systems is one thing, but making them trustable and reliable within the margins of error that we're looking at is really hard. Yeah.
Are the locations of the drone races released?
I'm sorry?
Are the locations of the drone races released?
Not publicly, but I think I can tell you, right? This is a cone of silence. We're going to have one in St. Paul, Minnesota, one in Phoenix, Arizona, one in Orlando, and one in Washington, D.C. We're going to announce the full information on August 14th, guys. So check out the Drone Racing League's website. Check out lockheedmartin.com/AlphaPilot. More coming. And we're going to release footage and specs of the drone, which I think is really cool. It looks like a flying stingray or scorpion or something like that. It's got a really unique three props are downward facing and the rear one's upward facing. And it's got a ruggedized GPU case right in the middle. And it's pretty cool looking. So stay tuned for that. Yeah, in the green.
What are the current limits of AI right now?
The limits of AI? If you go back to the general definition of AI, we're using it for specific applications, but that generalized intelligence capability is something that is a limitation. And that's why we think In our industry, the future is not going to be AI-based. It's going to be AI-augmented. So I don't think you'll ever see humans not flying airplanes. I think you'll just see a high level of assistance, right? Because you're going to need that generalized intelligence and nuance that a human brings. And that's something that's really hard to engineer. So I would say that's probably the biggest limitation. Yep. In the orange, go ahead.
Where do you see AI in 10 years?
In 10 years, I see AI as being, okay, so I'll put it this way. If you were a hiring manager at a company and someone came in and interviewed for a job, 10 years ago, 20 years ago, you might ask them, can you type? Are you good with email, right? Today, nobody was asked those questions. It's a baseline capability, right? Everyone assumes that if you're applying for a job, you're going to know how to work email, you're going to know how to do word processing, right? I think in 10 years, a certain base competency in AI is going to be one of those skill sets you take for granted, right? Of course, everybody knows how to do some basic programming, right? Because it's so pervasive. It's going to, if you're working with data or a large set of, like a large client network or anything on the technical side at all, right? It's going to be a prerequisite that you know some level of AI. So that's how I'd answer the question, that it's just going to be so commonplace that we kind of take it for granted. Mm-hmm. Sure.
Is it ever a concern with giving computers too much control?
Yeah, I think for whether you're talking about a weapon system or something like humanitarian aid, disaster relief, which is a really great test bed for a lot of this technology that we're working on right now. Giving an AI too much control in any scenario is a problem, right? You have to make sure that it's trustable, it's validated. Even when you're doing things like fighting in a combat zone, you have to follow a code of ethics, right? So you have to make sure the AI you employ can guarantee that it's going to behave the way it needs to behave and follow the guidelines that you're providing. And that's why I think, as I was saying, we are always going to see a human in the loop at some point. We say different scenarios, human in the loop, human on the loop, human off the loop. In the loop means the human is a choke point. Every decision goes through a human. On the loop means that the human is watching the AI go through the decision process. And it can intervene at any time to stop it or change the course. Human off the loop means the human has nothing to do with it. It's completely going on without their control, right? I think the way that you prevent the things from happening you're mentioning is you always keep a human on the loop, right? So there's always an opportunity for a human to correct the course if they don't like what they're seeing. Yeah.
Like pilot, right? He's on the loop, and like an AI is flying a plane. Do you think like his skill set needs to be more advanced than it is today, or like less advanced as the AI will be doing most of the flying?
I think it's just a different type of skill set. I think pilots right now are great at flying, but they may need to learn new ways of interfacing with AI, right? Understanding the basic behavior of the AI, how it will likely respond to certain scenarios. So if they want to step in, they know how to interface with it. So I think it's more of a shift than a growth of skill sets. Yeah, you I think you first. Oh, thank you. My legacy? Oh, geez. I'm the guy who got fired for showing a poop emoji at a conference. That's my legacy. No, I hope with my program that people will look back in years from now and say, Lockheed Martin played a hand in helping AI, help catalyzing AI to reach a generation, right? And, my name might get buried in that, but, if the things I'm doing are a part of that achievement, right, I feel good about it. My mom the other day posted an article on Facebook about drones delivering syringes and blood to remote places in Africa. And my mom, like, she would like, if she ever talked about drones, it was like, I hate drones, and the kid that lives in the back has one, and it's so loud, and I think they should do away with them. And for her to post that means that the things I'm doing have already impacted somebody whose life is so isolated from the technology. So that was really inspiring to me. And I think if we see more and more people talking about AI, and not just saying AI is this scary thing, right? And they say, oh, AI is what my son is studying, my daughter is studying, right? It's they're getting jobs in these fields, right? And it becomes more part of the personal life. If I feel like what I'm doing with AlphaPilot has a role to help get that started, I'm happy with that legacy. Oh, thank you. Yeah, go ahead.
Such as writing their own novels or writing their own programs?
I don't know, but I've seen some examples of Joan jokes, and they're not good. They're really bad. But I think music and things like that if there's some kind of pattern underlying it that works, I think at some point, yeah, you'll see that. I think there's probably a pattern to jokes too, if you really study it enough. There's a timing and a cadence element and a certain level of wittiness. So I think everything's feasible. Just those things are harder than other things.
We're just going to do one more question.
Uh-oh, okay.
Don't take it from here because you want to lunch with that.
Okay. All right, you're jumping out of your seat, literally. So.
Describe MEA for what are some other applications what are some other applications of AI in space exploration?
So another one that I know of is when we're getting ready to send humans to the surface of a planet, they want to send probes down in advance to check the environment's okay, collect data on weather patterns, search for water, things like that. And sometimes they have to communicate information back to the humans or back to the Earth, and the time delay is just too long for humans to say, okay, now do this. Okay, I read you, now do this, right? So there has to be a certain level of artificial intelligence involved where the robotic instruments can make their own decisions that have to be made faster than a human can respond. So I'm sure there's others. I know that they're looking at life support systems, like you'd see in the movies, right? So things that make sure that the astronauts are healthy and they're doing the right things, looking at their speech patterns, their behavior, their cognitive functions. So I'm sure there's more, but those are just two that come to mind. If you got any ideas, let us know. Thank you.